All right, IBAASL2. Today we're going to continue with probability, but today we're going to look at a couple things called sample spaces, and we're going to represent things with Venn diagrams and a different kind of sample space as well. So in this first problem, in a class survey, Ricardo, Melina, Daniel, Maria, India, and James reported that they study environmental systems and societies. In India, Pietro, Matea, and Janine said that they studied geography. Ricardo and James were the only ones who reported that they studied Spanish, whereas Sophia and Yulia studied none of the subjects mentioned in the survey. Represent this in a Venn diagram. Okay, when I read through this, I see that we have like 1, 2, 3 classes going on. We got the environmental, the ESS class, geography, and Spanish. So the way you can make a Venn diagram for this is to start with a rectangle. Every rectangle is like the entire sample space. And you always label this U. U can also be thought of as the universal set. This is like everything that exists in the problem. Now, if you read through this, there's some people that are in multiple classes. Like for instance, like India is in both geography and in ESS. So I'm going to set up my E and my G circles, so they overlap a little bit. So I'm going to make one right here, where this is E. And then we'll make a G circle. So that's, E is the ESS class and G is geography. But then Ricardo and James say that they study Spanish. But notice that Ricardo and James also are in the environmental systems class. So there's actually a Spanish subset within this. So I guess I'll make a note about that this is called a subset because it lives inside one set. Now, in the book, they kind of put down their actual names, which we could do, I guess. Yeah, I'll do that. So this is Ricardo, James, are both in the environmental systems class and in the Spanish class. Then India is the only person that takes ESS and geography. So India is going to be right in the middle. And then Melina, Daniel, and Maria take ESS but not geography. So they're going to be here in the middle. Melina, Daniel, and Maria. Apologize for my small handwriting. And then Pietro, Matea, and Nadine take geography, but not ESS. So this is Pietro, Matea, and Nadine. But then they also say Sophia and Yulia don't take any of the subjects mentioned. So see, Sophia and Yulia are totally outside the box here. One thing I think can be useful is to go through and put how many people live in each section. So here, there's 2 people. Outside of that, there's 3 people. Here for India, there's 1 person. There's 3 here, and then there's 2 that are outside of everything. So that's representing the set with a Venn diagram. Now, I kind of want to make it bigger. I've never done this live during here. There we go. For the second part of the question, it says, use the Venn diagram in example 4 to find the probabilities that a student chosen at random is from a certain class. So for the first one here, studies ESS. Well, I guess for all of this, we need to know the total kids that there are. So if we add up all these numbers, 2, 3, 1, 3, 2, I believe that's 11? Yeah. So of that 11, so probability of being in the ESS class is going to be something out of 11. But then you have to add up how many people are in this entire circle right here. So I see a 2, a 3, and a 1. So that's 6 out of 11. That is the probability of being in that class if you're chosen at random. Part B says studies ESS but not Spanish. So ESS but not Spanish would be these kids right here, because they're in the ESS. Oh wait, I'm forgetting India as well. It falls into that category. So just outside of here would be 4 people: Melina, Daniel, Maria, and India. So it would be like 4 out of 11 as well. Part C studies all 3 subjects. Well, all 3 subjects, there's nobody that studies all 3 subjects, because like there's only 2 people in Spanish, and those people in Spanish don't study geography. So this is a 0 out of 11, which is, we can just say 0. Part D studies exactly 2 subjects. So this is only people that study 2 subjects. Well, there's these 2 people. I guess I could use yet another highlighter. Ricardo and James study Spanish and ESS. And then who else studies 2? Oh, India. India studies ESS and geography. So that's exactly 2 subjects. So if we add those 2 together, that's 3 people out of the 11. So the probability is 3/11ths. In a class of 26 students, it is found that 10 study geography, 16 study history, and 4 study neither history nor geography. Calculate the number of students who study both history and geography, hence find the probability. Okay, so they don't tell us to draw a Venn diagram with this, but I think that a sample space like a Venn diagram can be really helpful. So I'm going to draw a big rectangle. Every Venn diagram should start this way. Big rectangle to represent everything that lives inside the problem. Now we're looking at geography and history. So I'm going to do a geography, and this whole thing is the universal, and a history. Now looking at the specific numbers, I know that everything has to add up to 26 students. I know that 10 are in geography and 16 study history, but 4 study neither history nor geography. This 4 studying neither is exactly where I'm going to start with my Venn diagram, because I know that 4 people live outside of that. Now that means in these 2 circles, that has to add up to 22, because there's a grand total of 26. But if you take these 4 people out of it, there's 22 left over, which means that, those 2 circles overlapping have to add to 22. Now, if I look at the 10 people studying geography and 16 studying history, that adds up to 26, which is bigger than 22. It's 4 bigger than 22, which means there have been 4 people double counted. There are people that study both geography and history. So those 4 people are in these 10 people, and those 4 people are in these 16 people. Because if I just tried to make it like if I put a 10 here and a 16 here, it's not going to add up correctly. There's going to be too many people in the class. So, of those 4 in the middle, 10 study geography. So if you take 4 out of the 10, that means there's 6 people left for geography, and there's 12 people left for history. Now this is a completed Venn diagram. Find the probability that a student selected at random from this class studies exactly one of these subjects. So the only people that are studying exactly one are these 6 people who only study geography, not history, and there's these people here that only study history, not geography. So Part A, sorry. Part A, the people who study both history and geography is 4 people. And part B, probability that students selected and study exactly one of these subjects. Well, that's going to be 6 plus the 12 out of the 26, which is 18 out of 26, which is 9 out of 13. Fully reduce those fractions, please. Last problem. You roll 2 6-sided dice and add the results together. What's the probability that you get at most 4, a factor of 24, and at least 8? I've seen people try to tackle this type of problem and without doing a sample space, and I don't think it's really possible. I think it's way better to actually do a sample space of everything that you can get. So here on the left, we have the roll from the first die, and then on top, the roll from the second die. So if I'm going to add these together, this is 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. 2 and 2 is 4. 2 and 3 is 5. 6, 7, 8. And then it will go down this way as well. 5, 6, 7, 8. 3 and 3 is 6. 7, 8, 9. 7, 8, 9. 4 and 4 is 8, 9, 10, 9, 10, 10, 11, 11, 12. So, you guys, all those pink numbers means that there are 36 possible rolls. Now, to answer these questions, A, B, C, and D, for part A, at most 4. Well, let's think. At most means you can have up to 4. So that would be these numbers right here. These are the at most 4. So there's 1, 2, 3, 4, 5, 6 out of the 36. So probability of at most 4 is 6 out of 36, which reduces down to 1/6. Part B. A factor of 24. Well, factors of 24 are 2, 3, 4, not 5, yes, 6, not 7, yes, 8, not 9, not 10, not 11, but yes, 12. So if I count all these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this one is 17 out of 36. Last one, at least 8. So at least 8, I'm not going to erase all those. I'm just going to use a different highlighter. At least 8. Well, at least 8 would be all of these numbers here, which I could count all those up by hand, but it's over half of them. So sometimes it can be quicker just to count up all the numbers that it's not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I take 10 out of 36, that means that this is 26 out of 36, which is 13 out of 18, I believe. Oh, I messed that last one up, you guys. At least 8. I was doing at most 8 in my head. My apologies. So this one, at least 8. I'm going to use a different highlighter just to confuse things more. At least 8 would be all of these numbers here. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 36. Which does reduce down to 5/12. All right, you guys, that's all I have for us today. Good luck with your homework. Please ask me questions in class.